Hello. How are you guys doing? Hopefully you guys are doing well. I don't know about you guys, but lately, man, I've been in a funk where I feel like it's Groundhog Day. I don't know. I don't know if it's just the end of the summer, like being tired and worn out or what, but I just get this. Seems like the same thing every Monday. Seems like the Mondays come so fast. And don't get me wrong, I love doing the live streams, but, Mondays can be a bear sometimes, but it's all good. I guess these are first world problems, right? That we are bummed because we have to go back to work or something. So I guess we should be thankful for some things, right? So, right on, cool. Yeah, I genuinely enjoy working. I really like problem solving. What I don't like is the business stuff. That's the stuff that drives me nuts. The quotes and different things like that. It's all just part of business. But like in general, I love problem solving and fixing things. And even at the end of a job, like where it's a really stressful one, I genuinely enjoy. I'm reading a question. Sorry. I genuinely enjoy, after I'm done, being able to look back and reflect like, hey, we fixed this problem or something. But, anyways, so I'm just going off on a tangent there. But hopefully you guys are all doing well. And hopefully you guys are getting ready for this holiday weekend we got coming up. We got a 3-day holiday weekend coming up here in the U.S. And I guess Primetime had said, I didn't know you guys celebrated it in Canada too. So cool. I don't know what other parts of the world celebrate. Is it Labor Day? I think it's Labor Day coming up. Yeah, I think I get them mixed up too. That's another one of those things. The holidays, I always get them mixed up, Labor Day and Memorial Day. It's not that I don't reflect on, the things that we need to reflect on, like on Memorial Day and stuff. But, anyways, just going off on a tangent again. So I need to stop and get back on topic. So let me see. So we got some questions in here. I definitely want to get to them, guys. Okay, so I'm out moderator today. So if you guys really, really make sure you put your questions in caps lock, I'm going to try to get to them. And if you guys, those of you that are in here, let me know if anybody's causing trouble and I'll kick them out. Just keep telling me and I'll try to get to them, okay? I appreciate it if you guys can help me out with that one today. And we'll see what we can do. All right. I really appreciate those of you that are in here and paying it to, and leaving me comments and stuff. It's really cool. So, all right. So I want to start off by talking about a service call that is driving me nuts right now. So if you follow any of my social media, you guys might see I had posted something on Facebook and Instagram about a master-built refrigeration rack that I was having a problem with, a compressor that's keeps going off on thermal overload. And I'm going to try to make a video on it. I've got a bunch of footage, but I got to be able to see if I can edit it together and make something usable. But it's an interesting problem. I took over a restaurant chain. I shouldn't say I took over a restaurant chain. I took over a couple new locations last year of a restaurant chain that I already did work for. And I inherited a problematic walk-in freezer. And when I say problematic, the customer has told me that, it's always been an issue. Every summer, they're constantly having issues with it. They've changed a bunch of parts. This is all that's been told to me. So my experience with this, I took it over at last summer, and I did have a few problems with it. And actually, to keep the unit running, I had to have a misting device on the condenser. I was having an issue with it, and that's not a good sign, but I got myself through the summer last year, and this year I kind of wanted to address it. And honestly, I kind of forgot about it until the summer hit this year, and then, it's obviously a problem now. So I've currently got a misting device on it to keep the condensing temp down, because what happens is my compressor goes off on thermal overload. So where I'm at is at a point where either I need to change the compressor, or I need to upsize the condenser in the receiver. And my logic is telling me that there's nothing wrong with the compressor and that the condenser and the receiver, between the two of them, are not sized correctly. The unit does not go off on high head pressure. It only goes off on thermal overload. Okay. I can tell that the previous person that had worked on this had done a bunch of work to try to resolve this problem. For instance, they put in a pressure limiting power head on the expansion valve to try to drop the suction pressure. They also disconnected the discharge line thermostat, which disconnects line voltage or control voltage to the compressor contactor if the discharge line ever gets too hot. And what else did they do? I think that's all that they did, actually. I think the high pressure control might have been bypassed, actually, too. ironically, I don't ever see the unit going off on high head pressure because the compressor will go off on thermal overload before we hit the high pressure cutout of 450 psi. It does have an auto reset high pressure control. So I've got everything hooked back up to the way that it's supposed to be, but I have to keep a misting device on here because what happens is my compressor goes off on thermal overload. So where I'm at basically, and this is the way that I have to approach this, is obviously I'm looking at the big picture, and I went ahead and did a few things. I noticed that in actuality, the power head was failing. So I went ahead and changed the power head on the expansion valve to a normal low temp power head, to a ZP charge, because this is a 404A system. And I went ahead and obviously vacuumed the system. No, I didn't have to vacuum the system down. Yeah, I did. I vacuumed the system down. That's right. I was sitting here thinking in my head what I did. But anyways, and then what I did was I just sat down and did some research on the equipment. Took the box calculations, measured the height, the width, and the depth of the box to make sure that the evaporator coil was sized appropriately. And it was. Then I went to the compressor and verified that it could handle the BTU requirements of the evaporator. And it can, but there's a caveat. On Copeland's product information, and this is something that I need to talk to Copeland about before I make one more, because once I open Pandora's box on this and let the facilities department know of this particular restaurant, it's going to be a pretty big deal. So that's why I'm trying to get all my ducks in a row. And mind you, the whole time while I'm doing this, the equipment is operating properly because I have a misting device on the condenser. I'm not a fan of putting the misting device, but it's not saturating it. It's just, it's not a problem at this point. So the customer's operational, everything's good. But what I need to do is either decide on whether or not I want to change the condenser, which I don't think I'm going to change the condenser. If I have to go that route, I'm going to talk the customer into letting me take this equipment out of the refrigeration rack and putting in a properly sized condensing unit next to the rack. Okay. Not a fan. And once I release the video, you guys will see I'm not a fan of this particular refrigeration rack just because of the design. It's kind of silly. When you take the panels off to access the compressor, you bypass the condenser because all the air, when you pull the panel off, it sucks the air from where you're at rather than through the condenser. So it's kind of a silly design. But and I'm going to get to your guys' question here in a minute too. So what I'm finding is researching the information on Copeland's product information. This compressor is operating outside the operating envelope of where it can be operating. So I basically looked at a chart, and it says, this compressor can put out this BTU, this many BTUs in this operating envelope, and it bases it off of condensing temp. I'm currently running about 140 degrees condensing temp when it's 110 degrees outside, right? Because we have a 30 degree over ambient condensing temp. So that's about what we're running. And when we hit that anywhere from 100 ambient temperature to 110 ambient temperature is when this compressor goes off on thermal overload. So the compressor has the right amount of oil in it. Okay. It does have a DTC valve, which is similar to a liquid injection valve, and the DTC valve is working correctly. The DTC valve has a temperature sensor that goes in the head of the compressor. Whenever the discharge temperature basically gets to a certain temperature, then the DTC valve is like an expansion valve. It meters liquid refrigerant into the compressor to try to cool down the compressor and keep it from overheating. So we know the DTC valve is working properly. So everything is pointing me in the direction of this compressor being undersized and not working correctly for this type of system. But I just want to get all my dots in a row because like I said, once I open Pandora's box, it's going to be a big deal because they're going to have to spend a lot of money to properly fix this thing. Another interesting thing is amongst my diagnosing, and I mentioned this, I might have mentioned this on social media, but amongst diagnosing everything, I'm going through the rack and I kind of already have it in my head that I think we might have an undersized condenser. Then I find some paperwork in the rack that says this particular refrigeration rack should have been sent to another restaurant location in Boulder, Colorado. Okay. So then I'm like, wait a minute. We're in Menifee, California, and that's Boulder, Colorado. Totally different condensing temps. I did confirm with the manufacturer, though. I don't know where that paperwork came from, but they're telling me, no, this rack is supposed to be at this restaurant, but they are telling me this rack was designed for 100-degree ambient when our average temperature is 110 and our extreme high is 115. So, but a 10-degree... being 10 degrees above what they designed it for, I mean, that doesn't worry me too much. That's not too far outside of the envelope. So It's interesting though, because all this stuff is going through my head and I'm just trying to be super thorough before I open my mouth to the customer. You know, I mean, I've kind of gave them an idea what I think is going on, but before I give them a final diagnosis and a quote to fix it. So, and basically now I just need to talk to Copeland. I went ahead and tried to call my Copeland rep in my area today, and he's out of town at the moment. So I was going to wait for him to come back just because I've talked to him before. I know I can get a hold of other Copeland reps, but anyways, I just wanted to run things by him. Basically, I've already talked to the manufacturer of the rack, you know, and they told me, no, everything's working correctly. And they've told me just to basically lean on Copeland. And so that's where we're at. It's things like this sometimes that can just make you want to pull your hair out, even though I don't have very much of it. It's just kind of driving me nuts. And the fact that I'm so thorough is probably my worst enemy, because, you know, it just makes me, you know, just really, really look at everything. So, so I saw a bunch of comments in here, and I want to try to get to this. And let me see. Does the capacity of the compressor match the coil? So the capacity of the compressor matches the coil, but on Copeland's product information, it says that this compressor can put out 9,000 BTUs at 105 degree condensing temp, which seems really strange to me, because why would they rate something at 105 degree condensing temp? That seems very, very low. Basically, that's like 70 degree ambient. So that's an interesting one. Now, let me tell you that if I didn't say it already, this is a low temp compressor. So our problem is especially once we get down to the low temps, we have the high compression ratios. And that's when we really, really run into an issue. So, but yeah, I mean, I don't know if that's a misprint on Copeland's product information stuff where it says 105 degree condensing temp, or not. But basically, yeah, it says 9,000 some change at 105 degree condensing. So that's why I really know what's going on with this, but I want verification from the manufacturer, from Copeland, you know, to tell me this is what we need to do, you know, and just to verify everything. The DTC is feeding. Now, whether or not it's enough, Matt, that's a hard one, because how do you measure if it's feeding enough? What I did do, I actually went back there today because I was working on another piece of equipment at this restaurant, and I actually did go up and measure the DTC valve, I mean, just to verify. And so what I did was I attached a temperature clamp about 3 inches away from the discharge of the head of the compressor on the discharge line, and basically at about 190 degree discharge temp, that DTC valve was feeding, you know, and it was getting cold. The other thing I did do too was I pulled the DTC valve apart. I pulled a strainer out of it because there's a strainer on it, and made sure that the strainer was not plugged up. It was sparkly clean. I did not have to clean the strainer at all. So I believe the DTC valve is working, but it's always a possibility it's not. You know, it's a hard thing for you to measure because, you know, the capillary could be going bad on it. There's so many things. The other thing I did today too was I took the sensing element out of the head of the compressor and put some food grade silicone that's basically going to help with like a heat sink. You know, I put some food grade silicone in there so that way it might get a better temperature, and maybe it was losing. I don't know. You know, I read something about that, about putting some kind of a heat sink in there to help actually sense it more accurately. So let's see what we got here. And I'll try to get to... Yeah, how do you deal with calcium with a misting device? That's a horrible thing out here, Glenn, because we have horrible water, and then it's very dry. I think on my thermostat today... Actually, let me look at it right now, and I'll tell you. We have very dry conditions here. So we are evaporating that water really quick, and then the calcium is being left behind. But right now I was monitoring, because I'm not like saturating the condenser. It's not, so right now outside it's 98 degrees in the evening, and we have 22% relative humidity. So it's very dry outside today. And I think I saw it down at 15% earlier. So yeah, that stuff evaporates really quick, and the calcium gets left behind. So that's a big problem with the misting device. And when I say I have a mister on there, I mean, it's pulled back about 3 feet, and every once in a while it hits the condenser. I did have a bigger misting device on it, and then I found out that the the refrigeration rack actually has a water leak inside of it. And when the big mister was on there, it was saturating it, and then it was just leaking into the building. So that was a whole nother mess. So anyways, it's just like one thing after another with this thing right now. So, all right, let's see what that. So inside my house right now, Matt, it's 43% humidity. I'm actually looking at my thermostat app right now. So, but yeah, so it's 22% outside, 43% inside. So, but my AC is running right now. All right, so I'm gonna go ahead and get to some of your guys' questions in the chat. Enough talking about what I was doing. So let's see what we got here. So what's the oldest refrigeration system I've ever worked on? I would say the oldest thing to talk about was I felt really bad doing this because it was crazy taking it out, but I took out a 10-ton carrier split system out of, actually I can talk about it because it's not a restaurant out here anymore, but it was out of an old Joe's Crab Shack restaurant. And it had a 06D Carlisle compressor in it. The compressor was in the air handler. This was up in an attic. This was a really unique design because there was just a condenser on the roof, and then the air handler was downstairs. And if I remember right, that system was from the 60s. That was probably the oldest air conditioning system I've worked on. And then refrigeration systems, I don't think I've worked on anything that old. Maybe 70s, 80s, you know. But nowadays, refrigeration doesn't last as long for sure. You would still see some of those older air conditioning systems. And even that carrier that I mentioned, that was probably 10 years ago, 12 years ago that I did that. And what a bear that was taken apart. And I felt so bad too because we ended up putting York equipment back in there. I don't know why, because I'm not going to pass judgment, but yeah, I ended up putting York equipment back in there. I think I did it because of the air handler size. I think I was just basically looking at something that was comparable to what was in there. And I know it won't last nearly as long. You know, it's just crazy. What I pulled out took like almost 3-4 days for us to get it out with just 3 guys. We had to cut it up into pieces. It was all steel and heavy, and you know, what we put in there was super light and cheap. So, all right, let's see what. Is the superheat set properly? Is there enough suction cooling come back towards the compressor? John. Yeah, so the superheat at my evaporator is about 8 degrees. I measured at my compressor, and it was a little bit high at the compressor, I think. I think it was at the upper end of the 40s coming back to the compressor, which isn't too bad. It might have been at the low end of the 50s. I'd have to look back at my paperwork. But yeah, we had superheat coming back, so we have suction cooling coming back. But yeah, what's interesting is it just overamps when you have your. So I'm leaning towards this compressor's just operating outside of its envelope is what I'm leaning towards, and or the condenser's undersized, because when you take that misting device off, head pressure immediately drives up, yeah, compressor just starts to climb in amps. Even with the misting device on there, I think the compressor's running at like almost 10 amps, and I think it's rated at like 9 or something like that, or 10 or something like that. But it's right on the envelope, you know. So, all right. So Ray, on my latest video, did I replace the fan or just the motor? Oh yeah, grease fires. Yeah, Burger King. Yeah, that sucks. So I did not replace the motor yet. If you looked at my recent video where I showed an exhaust fan, there was actually 2 exhaust fans. So the second fan that I showed in the video, we actually replaced that fan. And the first fan, the one that was laying on the ground, I'm submitting a quote to go ahead and replace that fan. At this particular restaurant, all of those fans are from 2004, I think, and they're just getting worn out. They're dirty inside. It's time to replace them. Vibrations and different things. Unfortunately, one of the things that I find in restaurant work is they realize, some restaurants realize that the refrigeration needs to be maintained at least somewhat. You know, and what I tend to see them lack on is the grease cleaning. So I've noticed the intervals of grease cleanings on the exhaust fans going down and down, where we get more grease buildup in these fans. And when we get grease buildup inside of them, we tend to start to notice more vibration issues and bearings going out and different things like that. So you'd be surprised, for those of you that don't know, the least, just the slightest amount of grease on an exhaust fan, the airflow is reduced. And they go out of balance really easy. You can actually bend a shaft on an exhaust fan or bend a wheel just because there's 1/8 of an inch of grease buildup on it. And if there's a little bit more on one side more than the other side, it'll, over time, because of the centrifugal force, it'll actually start to bend components inside there and create problems. So definitely interesting. People need to be cleaning a lot more of their fans and different things. So, all right, let's see what else we got. All right. How do I like working on those greasy exhaust fans? Yeah, I mean, it's not the greatest thing, but, I don't clean them. Heck no. I don't clean those fans. They got companies that do that. We just service them. So it's just, it doesn't really bother me too much. So do capacitors and circuit boards fail as often as regular run capacitors? Zach. I don't know, man. I mean, honestly, I don't ever try to change a capacitor in a board. If a board fails, then it's time to change the board. I don't know. I have seen some videos where people try to repair circuit boards and different things, but that's not really my cup of tea. I don't have the time to do that. So if a board's bad, I'm changing it. So, all right, let's see. Let's go to some of my stuff right here. So I got a couple things I want to talk about. Oh, I don't think I've seen either of them in here, but I do want to say congratulations, social media guys that are out there, Tersh Blissett and Andrew Greaves, aka HVAC. Both of them were nominated, actually won the 40 under 40 for the ACHR whatever news. I saw it come across Facebook today. That was really cool. So congrats, guys, and I'm happy for you guys. So does the rack have a swamp cooler, Kyle Carmen? No, it doesn't have a swamp cooler, Kyle. And that's another thing too that I had thought about doing. If the customer didn't want to go as far as putting a new condensing unit on there, I could definitely just throw a swamp cooler up there and kind of pre-cool the rack. That would definitely be a better way than using a misting device. So I think I even mentioned that I might just do that on social media. So, all right. Let's see what else. McDonald's has an interlock on their exhaust systems and it's a drag. Yeah. So, Fluke 196C, you've been looking for the hook on my rope. Can I mention where I got it? Yeah, I got it from RSD, Refrigeration Supplies Distributors, but I believe you can get them at other supply houses too. It's made by Klein. And while I'm talking right now, I will actually find a link for you and put it in the thing. So let me go to here and get you that link real quick. So let's see what else. The other video that I had uploaded was a walk-in freezer not working, and I wanted to point out something. So walk-in freezer, I ended up replacing a TXV, and I apologize. There was a couple things that I didn't put into that video that I know people were asking me about. Why didn't I check the defrost? I had actually recently just done some work on the defrost system for that unit, so I did know that the defrost system was working properly. So that was on that particular video, and that's why I leaned towards the diagnosis of the bad TXV. I also have another video that I'm working on too. It's almost the same exact evaporator coil where we have it's an opposite problem. We have it actually had too low of superheat, and it was another one of those Emerson walk-in freezer valves. Not trying to pass judgment on Emerson, but I am not a fan of the Emerson expansion valves. I really prefer the Copeland ones so much better. So I'm sorry, Sporlan ones. Sporlan expansion valves so much better. So, and here I've got a link right now to this hook. I'll put it in here. Thanks, Fluke. I really appreciate it, bud. So here's a link to this hook if you're interested in it. It's an Amazon link. You can click on that. You could just at least find out what the part number is on it, and then you can go to RSD or wherever, or you can get it from Amazon, anything you want. You guys, I do put links in the bottom of my videos. I personally buy my tools from supply houses or from TrueTechTools.com, but I do throw Amazon links inside of there. I do get, it's like an affiliate link, so I get a small commission on it. If you use them, if not, I strongly suggest that you guys shop at supply houses though, because we need to support our supply houses. And I really do like TrueTechTools.com too. So, but some of the stuff you can't get from there. So I do find myself having to go to Amazon for a few things that I find. So, all right, let's see. Yeah, I just really don't care for the Emerson TXVs, but I don't want to talk crap on people, dude. So, all right, so let's see what else we got in here on my list of stuff to talk about. So, okay, I got a couple questions. So this person had asked me a question, and they said, this person asked me if so I can kind of tell that this guy's a business owner, but I think some of these points are really important, so I still want to answer them. So I'm just going to read his question verbatim, okay, and then I'll try to answer it as best as possible. So it says, my freezer is inside of my cooler, so the only air that gets to the freezer is 38 to 40 degrees. So and he's asking me if door gaskets are that big of an issue. He would not think they are, okay? And he's also saying that how important is it that the freezer door is shut inside the cooler? He's asking me, okay? And he also is saying, does the ice on the ceilings and walls contribute to the problem? So if you're watching this, I'm just going to say your first name, Dan, that put this in here. So a walk-in freezer it's very important that we maintain all closing hardware on the doors, that we keep the doors shut, and that we maintain our gaskets, okay? Gaskets are very, very important, and I think a lot of restaurant owners don't really understand the importance of a door gasket, okay? On a walk-in freezer, if you have a door gasket that's failing, what you'll tend to notice is a lot of ice around the doors, and then you'll have doors that get stuck, hinges that go bad, water gets on the floor, people slip on it, all kinds of problems, okay? Keeping the door in your equipment shut is imperative, all right? On a walk-in freezer, it's even more important. I shouldn't say more important, but there's some more things that can happen in a walk-in freezer too. Leaving a door open on a walk-in freezer can lead to a lot of freeze-up problems, meaning that the unit can freeze up, the coils can freeze up, and then the unit will stop working. Something that you have to understand and remember is that ice is it starts to form at 32 degrees, okay? But ice acts as a great insulator. So once ice starts to build up, it actually insulates and doesn't allow the temperature to drop anymore, okay? So once you get a lot of ice on your evaporator coil, the airflow doesn't happen properly, then heat transfer doesn't happen properly, and everything goes down the hill. So always want to make sure that you're maintaining door gaskets, even on your reach-in coolers, everything. Door gaskets are imperative, okay? We need to keep that outside air out of that box in order for that box to work properly. So it's very important that we shut our doors, maintain our gaskets, make sure that our closing hardware, the hinges should be self-closing, and you should have a door closer on there that's closing that door too, okay? Very, very important. Let's see. Yeah, all right, let's see what else we got in here. Okay, the next one I want to get to is another question that I had I'm just going to say the first name, I'm not going to say the last name, as a person named Justin. And he asked me, he has a question about temperature difference when troubleshooting refrigeration systems, or a TD. He said he's using a walk-in cooler, for example, and some of the classes he has been in, they were taught that TD is the difference between the air and the saturation temperature of the refrigerant, okay? However, he thought that in one of my videos, he saw me use supply air versus return air, and this is on refrigeration, okay? And he's also heard of other people using supply air versus return air. So he just wants a clarification on what the temperature differential is, okay? So let's differentiate between two things. And this is a very confusing topic, especially for people coming from air conditioning to refrigeration. A TD of a system is the difference between the return air, or the box temp, and the saturation temp of the refrigerant. Okay, that is our evaporator TD. The delta T is the difference between return and supply air. Now, in refrigeration, we typically don't use delta T very much, but I am going to give you guys a really good way to use delta T, okay? But it's very important that we understand the difference. So our system is designed, typically, most coils out there, walk-ins and walk-in freezers, are designed with a 10-degree TD, unless an engineer's gotten involved and they're doing some funky stuff inside of there, okay? Most systems are sized for a 10-degree TD. Which also is a really good way, and I've mentioned this many times before in my videos, is that we can use our TD to help us predict what our pressure should be, right? Because, and I'm not going to steal this, I believe it was Jim Bergman had mentioned on social media or on YouTube one time, maybe on one of Brian Orr's podcasts, you know, that you really have no business putting service gauges on a system if you don't know what the pressure should be before you put your gauges on there. You should be able to predict what your pressure should be. You don't want to look at them and say, that doesn't seem right, okay? Typically, most systems, refrigeration, walk-ins and freezers are designed with a 10-degree TD. So if that being said, if we know what our our box temp should be, once we're close to our box temp, we can predict, assuming that we have a 10-degree TD, that if we have a 40-degree box, that our saturation temperature of our refrigerant should be about 10 degrees below that. That gives us an idea on our saturation temp on the suction side. Now, what about our liquid or discharge side, right? We can make some assumptions, just rules of thumb, all right? Microchannel coils are going to be about 15 to 20 degree condensing temp over ambient. That's a rule of thumb. No, don't hold me to that, okay? And older tube and fin condensers are going to be about 25 to 30 degrees over ambient, condensing temp over ambient. So that means that the return, or the outside air, is 100 degrees. On a tube and fin condenser, you can kind of assume that your condensing temp is going to be about 25 to 30 degrees over ambient. And on a microchannel, 20 to 25, okay? But again, rules of thumb, you can't just run with those. Manufacturers get involved, they start tweaking things and doing weird stuff, but that can at least get you in the ballpark. So that kind of gives you an idea, okay? So hopefully I answered your question there, Justin. let's get to, let me see if I'm missing anything. Did I get the Measure Quick update? Great. Thanks for bringing that up, Nathan, because I actually have that on here. So I noticed just before I went live that Jim Bergman had posted something on Facebook, and he said that Measure Quick released their refrigeration profiles and stuff. And I have not had a chance to use it yet. So I will definitely be updating it and checking it out. I am a huge fan of Measure Quick. And this actually answers another question, because someone asked me what, I'm going to say your first name, Anthony, asked me what's the name of the HVAC program that I use on my tablet. And that is called Measure Quick. So I use a Samsung tablet. There's links in the video notes of this video for the tablet that I use. But Measure Quick is the application that I use, and it's a great air conditioning application, and I can only expect the refrigeration application that was just released today to be amazing too. So I highly suggest, if you guys aren't already, download Measure Quick. It works with a lot of the, and I have no affiliation with them, guys. I just like promoting the products that I like, okay? So it works with all kinds of different probes out there. Currently, right now, I believe it's Testo and Field Piece, but I know that there's a lot on the about to be released. So there's a lot of good information coming out with some cool probes. So there's a lot of cool stuff with that coming out soon. So Measure Quick, yeah, I love it. Now, Ray, so you did say Sporlan is best in the industry. I have not gotten this confirmation from Sporlan yet, but I did get a confirmation on Brian Orr's podcast, I believe that he did with Jim Bergman, where Jim said that Sporlan has decided to go ahead and integrate their probes with Measure Quick. So that's just hearsay. Hopefully that's true. I wouldn't think Jim Bergman wouldn't say it on the air live if it wasn't true, but that's really cool too. So the Sporlan probes supposedly soon are going to be able to be used with Measure Quick. So that's an interesting thing too coming out. How often do I rebuild TXVs? Company policy is replace the whole thing to be safe. Zach, I do not think that is a problem. Okay. My company policy, I don't have a policy per se, but it just depends. If I'm working on a reach-in cooler, I'm probably not going to put a power head on it because it's a pain in the butt to change. If I'm working on a walk-in and it's got symptoms of a bad power head, yeah, I'll change the power head. But if one of my guys calls me and I don't have a lot of confidence in the diagnosis or in the ability to change just the power head or something, I'll probably lean more towards changing the entire valve. So I would say that I probably lean a little bit more towards changing the valve. Now, I will say that there's not a lot of components that actually fail inside of an expansion valve, especially when we're talking about the Sporlan ones, okay? And I'll actually grab one right here. Hold on. So in a Sporlan expansion valve, and I showed this last week, here's a Sporlan expansion valve right here. So you've got a couple components. I know that's probably, I don't know if my camera's focusing very well. There you go. So you've got a spring, you've got a seat that has the pin on it, and it just goes up and down. And then you have the push pins right here, and you have a power head. The most common part to fail on this valve is the power head. And usually what happens is the sensing element rubs up against something and the refrigerant charge leaks out of the power head. That's a very common issue with these. A lot of times on these valves, they have a strainer on the inlet and you can pull the strainer and clean the strainer. And now this is a flare valve. I don't use flare expansion valves anymore. That's why I took this one out of my shop stock and cut it up. But there's not a lot of components to fail on this valve. Now what can happen, in my opinion, we get a lot of failures when we don't do proper system procedures. Basically, we're not following proper refrigeration practices. If we're not evacuating the system, if we have contaminants in the system, then sure, you could have things gumming up the inside of this valve, kind of like the debacle that happened with the rust inhibitor in the unnamed compressor manufacturer. That's probably one of the biggest out there, and they had all kinds of expansion valve problems. That wasn't necessarily the problem of the expansion valve. Actually, it wasn't the expansion valve problem at all. It was that there was contaminants in the system that weren't meant to be in the system, and they were clogging up orifices and gumming up needles and different things inside those valves. So hopefully that answered your question there, bud. Let's see. How hard is the Hoshizaki ice machine combo drink dispenser to fix? I've never worked on the drink dispenser portion, Ray, but any of the Hoshizaki dispenser machines, they're kind of a pain. I mean, they're not horrible. It depends on which one it is. A lot of times I don't do a lot of dispenser work, but the little bit that I have done has been pretty difficult because they're usually tucked up in a tight place. and they're kind of hard to get to the parts. I would say the majority of my frustrations with ice machines have to do with the installation locations and not necessarily the machine. So for instance, I love working on Manitowoc Quiet Cube ice machines. Those are the #1 machine that I work on. But what I hate about them is they stack 2 Quiet Cube machines next to each other on a bin, and you have no room in there to get in there and change components. If you have to change thermistors, which fail on the ice machines often on the Manitowocs, they're a pain in the butt. So I would say that how hard are the Hoshizaki ones to work on? I don't know your particular model, Ray, but I've never worked on the drink station portion. I wouldn't work on that. I would just do the ice machine. But they can be kind of difficult. I've worked on some dispenser, the DCI or the I can't remember the dispenser model numbers. I like hospitals too, but generally, as far as reliability and dependability, I'm going to go out on a limb and say the Hoshizakis are usually the better ones. They last a little bit longer. But, Manitowocs are pretty much right up there too. I think that a lot of people, like I would say that I really don't like working on Scotsmans and isomatics, but it's just, in my opinion, because I don't work on them very much. If I worked on them more often, I'd probably be more comfortable with them. So how do you determine power limiting TXV, and are they only for low temp applications? So Ralph, on the power head of the expansion valve, see, I cut this power head, so I don't have a new one, but on the power head of the valve, there's going to be a pressure charge right here, and it'll say VC, Victor Charlie, or Zebra Paul, okay? The first letter indicates the refrigerant. The second letter indicates what kind of head is on it and what kind of charge it has. So like a ZP charge is going to be a 404A/502 low temp pressure limiting. So the P means pressure limiting. HVAC Rookie, thank you very much for that super chat. That's really cool of you guys. You guys that put those in there, those are not expected, but they really do help. So thank you so very much, guys, that are doing the super chats. So you would know by the number on the power head itself, and it's going to say Zebra Paul. No, it is not just on low temp, because we do have pressure limiting power heads on air conditioning systems too. So Sporlan has it on their power head. Now, other manufacturers like Emerson and Danfoss, I'm not too familiar with how their power elements work. I'm just really familiar with the Sporlan power elements. So you'll know, though, basically at the end of the number, it'll say VCP. And that'll tell you, VCP would be R22 medium temperature pressure limiting. So, or RZP would be 502 low temperature pressure limiting. SCP would be 404A, which 404 and 502 is the same power head. So you guys get the point. So you can find more information on Sporlan's website. Ask the Google, as I said earlier in the chat. Just ask the Google Sporlan power head pressure limiting and just put that in the Google search and it'll come right up. So all right, let's see what else. Hey Rick, how you doing, bud? Northwest Ohio HVAC videos. Good to see you in here, man. Hey Adam, how you doing, bud? All right, let's see what else we got questions wise, guys. Okay, so I'm gonna get to another thing I have in my list of stuff to add. Okay, so really good one, guys. This person, your name, I want to say your first name, your name is Bo. I think that's how you say it. So he says that and I'm going to read this kind of verbatim so that way you guys kind of get an idea what he's telling me, okay? And then we can kind of go through this and I can help him to understand and hopefully help someone else to understand this too. So he's got a walk-in cooler that keeps freezing up. He says it's for his friend. I don't know whether or not that's true. I'm not judging you if it's not. You can send me a question if you're a business owner too. I don't mind helping people, okay? So he has a walk-in cooler that keeps freezing up. If this person isn't a restaurant owner, I can tell that he's probably a air conditioning technician by the way that he's trying to work on the system. And there's nothing wrong with that, guys, okay? Nothing wrong with wanting to learn. There's no stupid questions, okay? But if you can have a better informed question, that will definitely help. And this guy has a pretty informed question. So he lists off what his stuff is. So he tells me what the low pressure control cutout is. It's cut in at 20, cut out at 5. He's got a high pressure control cut out at 400 auto reset. He says his sight glass is here clear. His superheat is 10 degrees. His subcooling is 5 degrees. His box temperature is 40 degrees. And then he lists his low pressures and his high pressures. I don't see saturation temps, but I can figure that out by myself, okay? The pressures aren't the point. Let's get to the important part right here. So he thinks that he's trying to bring the low pressure up, okay? Because his logic is that the system's freezing because the low pressure is too low. So he's adding more refrigerant to bring the low pressure to 76. This will not freeze on the evaporator, but the low pressure does not change when he keeps adding more refrigerant. Only the subcooling gets higher, all right? So what is happening here? What's happening is you're working on a refrigeration system and you're trying to think about it like an air conditioning system, okay? And you also got to understand, and I mean, that's not even the right way to think about it with an air conditioning system either, but your logic is a little skewed because you're not going to add refrigerant or remove refrigerant. Once you have a clear sight glass, you're going to leave it at that. You're not going to change anything else. And he's saying that the evaporator only has a thermostat control solenoid valve, so it's a pump down system. The evaporator fans are always on, you know, so he goes through all that stuff. Dallas, thanks so very much, man. HVACR North, Zach, awesome guys. Thank you very much. Okay, so your logic is a little skewed, okay, and there's nothing wrong with it. You just need to understand a little bit more. So once you have a clear sight glass on your refrigeration system, what you want to do is you want to look at your saturation temperatures of your refrigerant, okay? And let me pull up my chart here and look at the saturation temp on I'm going to use a mobile app here real quick. And he says it's 404A refrigerant. Does he actually tell me the refrigerant? I can't remember. Yeah, he says 404A refrigerant. So I'm going to go ahead and input the pressures and see what we come up with. Okay, so at 68 PSI, the saturation temperature of 404A is 29 degrees, okay? So his logic is that he's getting that evaporator too cold, and that's what he thinks is freezing it up. Whether or not that's true, I don't know, because there's a lot of variables that go into that. Is your airflow correct? Is your coil clean? Is it bent? Are the fan motors going in the right direction? Okay. Before we start playing with the refrigerant charge, we need to verify everything's correct with the fans. What kind of an evaporator coil is it? Does it suck from the inside out? Is it a ceiling mounted? Is it a wall mounted? If you want to send me more answers to my questions here, you feel free to send them to my email. Send me pictures. Show me what you're dealing with. Okay. What I need to know, Bo, is the system working properly as far as airflow goes? Okay. Before we start adjusting refrigerant charge and stuff, I'm a little leery that you've added refrigerant. Okay. Because we don't add refrigerant to change the saturation temperature once we have a clear sight glass on a refrigeration system. If we need to change our saturation temperature or change we might adjust our expansion valve, okay? So I don't really have an answer for you, Bo, but I'm hoping that you can understand a little bit more, and then you can give me some more. Let's see what we got going on. How do you determine the proper defrost cycles for your walk-in freezer? Jeremy, so what you want to do on a walk-in freezer is you typically want to start, let's make sure first that your limit switches are working correctly, okay? So you have defrost termination switch and you have a fan delay switch, okay? We got to make sure that they're working properly. So if we want to test the defrost termination switch, what you want to do is set a really long defrost. Let's set it for 2 hours. You're not going to let it go through a 2-hour defrost, but just set your defrost for 2 hours, turn a stopwatch on your phone, put it into defrost. Within about 20 minutes, more than likely, your system's going to pop out a defrost if your limit switch is working correctly. You have a defrost termination limit switch. If it's not working correctly, then we need to fix that, okay? Our fan delay switch, when it pops out a defrost, what you want to do is you want to go downstairs and see if your evaporator fan motors are running right away. They should not be. There should be sometimes it might be 30 to 90 second delay, maybe 2 minutes at the most, delay, and then your evaporator fan motor should turn on. If that's the case, then your evaporator fan delay switch is more than likely working. All right, once we know that our limit switches are working properly, what I would suggest you do, here in Southern California, we have a drier climate. I think I told everybody that we have about 20% outdoor humidity right now, and I think in my house it's about 43%. So we can expect that to be pretty common inside of our restaurants and stuff too. So we don't have high humidity, so what we do is we start with 4 defrosts a day for 30 minutes. Now, if you go to some of the really humid climates, you may need to change that a little bit, but I would suggest you start with 4 defrosts, and you set them for 30 minutes. That 30 minutes is a fail-safe time. And usually the limit switches will kick it out of defrost before the fail-safe time ends, okay? So I would start with 4 defrosts a day is my opinion, and then adjust accordingly from there. If that doesn't solve your problem, you can go ahead and put 2 more defrosts in there, or you can try adjusting the times longer. But what you want to be careful about is you don't want a defrost to be too long. I wouldn't suggest setting a defrost for more than 30 to 45 minutes, because once you go past that, you're going to have condensation issues and different things that can happen too. So hopefully that answers your question for you, bud. Let's see what else we got. Let's see. Nightbot's going kind of crazy. Double posting things, huh? All right. Please talk about Silver King units and how Tito. Okay, so you know, I don't want to bash a particular piece of equipment, but I will say that Silver King reach-ins, if you work for a certain restaurant chain, Rel, thank you very much, man. If you look at there's a certain restaurant chain that uses a lot of Silver King. We don't mention restaurant chains in here, which ones they are, but there's a certain one, and they have a lot of Silver King equipment. And Silver King can be a bear to work on, especially if you ever have to take apart their drawer racks. Oh my gosh, you want to pull your, I'm going to watch my mouth, but you want to pull your hair out trying to take apart drawer racks. So just accessing their coils is kind of a nightmare too. Tito, the one that Tito was working on, Tito 209 is his name in here, he was working on, is a very similar one, and it has 2 evaporator covers. And what I do is I slide one over, defrost an evaporator, slide the other one over, defrost the other evaporator, and try to get the covers out, because the covers are a nightmare. But I had to send one of my techs to change 4 of the axial fan motors on one of the Silver Kings the other day, and he said it was a nightmare because all the screws were stripped out. So anyways, I don't want to talk crap on manufacturers, but there's some out there that are worse than others for sure. So let's see what else. Guys, for those of you that are posting questions in here, try to make sure you post them in caps lock, because I don't have a moderator in here today to help me. So if you can, I don't want to miss your questions. So Nate Refrigeration, I see that you have ever worked on any Heatcraft units with a Beacon 2 setup, electronic expansion valve setup. You had one last week on a walk-in cooler that the expansion valve was stuck open 90 PSI low side. I have heard, I do not work on any beacon systems. I do work on the QRC, which is a dumbed down beacon system. Okay, it still uses the Beacon 2 board, electronic expansion valves. But I have heard some horror stories about the beacon systems, but I will say that majority of the time, again, I'm going to say that most of the horror stories that I find or see myself are because of improper installation. I could expect that an electronic expansion valve would not like to see sludge and crap stuck inside the valve, which would probably make it hard, okay? But I have heard about the issues with the electronic valves on the beacon systems. I personally haven't done any beacon work, so... all right, let's see what else. What other questions we have here? Do I work on Silver King milk dispensers? Brandon, I worked on a Silver King milk dispenser one time. Silver King called me out to do a warranty job at a particular coffee place. And yeah, I don't want to mention names. But anyways, I did a warranty job for Silver King. And they don't let me do warranty work after that job, because they only wanted to pay me like 45 minutes, and it was stupid. And I was like, no, you know, like I'd never worked on one before, and they sent me out there knowing that, and they sent me instructions, and it took me like 2 hours. I think I had to change the valves or something like that, which, you know, said, we need you to change these dispenser valves. Here they are. They sent them to me. I didn't diagnose them. They just sent them. So of course, when I went out there, I did big picture. I went through everything, checked everything out, made sure it was all working. And they didn't like that. They just wanted me to go in and change the valves and move on. And I said, if you want that kind of work, you need to call someone else. And they don't call me for warranty work anymore. So, hey, so be it. I don't care. Andrew Hicks, are you the only person that hates Traulsen? No. I mean, you know what? Traulsen has definitely fallen off the map as far as their quality. But let me say this. Traulsen used to be the best manufacturer of refrigeration when they used real stainless steel, when they were made in California. They were great, high-quality pieces of equipment. But they definitely are going down in quality, but I think they're doing it just to compete with everybody else, because you get these companies, the Korean companies and different things that come in, and they're making all these really cheap boxes, and basically if Traulsen doesn't make a lower quality box, they can't compete, so they have to. They still make some high quality stuff, but I would definitely say that their equipment that's produced today certainly isn't as high quality and easy to work on as the equipment that was produced 10 years ago for sure, and then 20 years before that it was even better to work on. So let's see. All right, I'm gonna put you in there for right now, Adam. Okay, so you got it until Justin returns. Kick ass and take names. Hopefully there's not any problems going on. I haven't seen anything going bad in here right now. So let's see what else we got. Do I like Trenton walking equipment? B-Wing tools. I've worked on a couple Trenton condensing units. I've installed maybe like 4 or 5. I do have to say they were pretty high quality condensing units as far as like how easy they were to work with and stuff and the components that they had. So I haven't had a lot of experience with them, but I thought they were pretty good quality. So that's pretty cool, Fluke 196. You worked on the home of the Traulsen owner. That's really cool. In my opinion, wet brand ice machine is the best. I'm a huge fan of Hoshizaki, is my favorite, but I'm very comfortable working on Manitowoc Quiet Cube machines. I tend to work on 95% of the ice machines I work on these days are the Manitowoc Quiet Cube, so I'm really comfortable and used to the problems that they have. But we have a running joke at my shop that our opinion is you can install a Hoshizaki and weld the front panel shut and typically won't have a problem for at least a year. On a Manitowoc, you screw the panel shut and you're going to have cleaning problems within a month. But it's just the different style of machines. I'm not trying to talk crap on Manitowoc. I love their machines. It's just the different styles of machines and the ability to have slime and different issues versus the Hoshizakis tend to have more calcium issues. So, yeah. What is my electrical background and what should and shouldn't techs be doing themselves? So my electrical background is I am not a licensed electrician. I am an HVAC contractor that is allowed to work on electrical within my components. I do not run electrical typically. I have done it in the past with an electrician helping me out or something. But for the most part, I just will install a disconnect switch. And if it needs to be something at the panel, it's very rare that I allow my technicians to open panels. I usually don't tell them to open panels. I tell them to leave them alone as far as like breaker panels and different things. I'm not saying that I've never opened up a panel. I'll typically, if I have an issue, I'll open up a panel to investigate, but I don't ever really do any work in the panels. So, you know, things are different on different parts of the country and different parts of the world. So I know that you go to the more union strong states and you're not allowed to touch electrical. You go to, you know, up north into Canada, and I've heard some issues with doing electrical and stuff like that. Here in Southern California, we really don't have that problem. And I try to solve as much as I can, but if I'm running new feeds and different things, then I'm going to lean on an electrician to do that work for me. Okay. But I'm pretty comfortable doing it. It's just, I want to be able to focus on what I do best, which is the refrigeration and air conditioning, and I'd rather have an electrician come in and do the work. But I will say too that there's times that I don't have time to wait for an electrician, so I'll run conduit and different things, or I've even ran the conduit and done all the work and then just call the electrician just to hook it up just to be safe. So personal preference. Yeah, Zach Trow, I think that's how you say your name. Is it possible to change defrost heaters inside the evaporator? Yes, it is. It is possible. It depends on what type of an evaporator it is. Usually if it's a wall mounted or the low profile coil, which is the one that mounts up on the ceiling and pulls the air and blows it out the front, those ones, the heaters typically slide out the side. You disconnect the electrical section and they usually will pull out one side or the other. And then occasionally there'll be little clips that hold them up to the bottom of the evaporator. If you're working on the ceiling mounted, like the reverse airflow, space miser coils, different things like that, those are the ones that are mounted at like a mullion coil in the middle of the ceiling and the fans suck the air up and blow it out the sides. Those ones typically have heaters at the bottom of the coil and they're hooked on with little hooks. The biggest tip I can give you is if you're going to change defrost heaters and it has hooks, order the hooks with it. A lot of times they don't ship the hooks that hold the heaters in place, and the hooks will rust and break off when you're trying to take them off. So they can be kind of a pain, especially when a coil is installed close to a wall. You have to bend the heater to get it out and bend the heater to get it in. So let's see what else. Oh, look at that. HVACR North got kicked out by Adam. What the heck, man? Don't make I'm gonna have Nightbot kick you out, Adam. That's funny. All right. Let's see what else. Who is the blue Adam guy? Let's see. Hopefully I made the real Adam a mod, because the fake Adam that was in someone's chat the other day, I was like, oh man, who's that? All right, let's see what else. Traulsen sensors go bad really quick. Yeah, they do, Raphael. That's probably one of the #1 failure things on a Traulsen reach-in, on a Traulsen freezer and reach-ins, is the sensors. I'd say Dallas, Ralph, thank you very much, man. That was really cool of you, bud. Really appreciate the super chat, bud. Thank you very much. Send me yours because I'm very green on dish machines and our go-to tech is requiring. Oh, okay. I don't know who you're talking to, Kenji, but there's lots of guys in here that work on dish machines. So um, let's see what else I got. Hey, Justin's in here too. How you doing, Justin? All right. Let's see what else we got. Let me get to my questions here that I have on my list. Okay, so this is another one too. It says, where did I get my ice machine education? This is a question that someone sent me. So, and I've mentioned this before, majority of my education came from trial and error. I don't think, I definitely learned by making a lot of mistakes. Nate Refrigeration, I'm going to answer your question in just a second. Let me finish talking about this, but don't forget to remind me to answer that question, okay? So, my education on ice machines came from trial and error, okay, and reading the manuals. I just Google HoshizakiIce.com, ManitowocIce.com, or Hoshizaki Western, whatever. Look up the ice machine manufacturers' websites. They have all kinds of great literature. Call the manufacturers themselves. Ask them for the books. Order the books when you're at the supply houses, okay? I will say that it is more difficult for you to get the ice machine books from, like, the wholesalers like United and Allied and RSD and Johnstone. It's going to be a little bit harder to get the ice machine service books from them. So you need to call the manufacturers direct and ask them for part numbers and help the supply houses if you're trying to go through a normal wholesaler with the part numbers and different things so they can order you the books. But I just did a lot of research and trial and error, messing things up, calling tech support. I'm not afraid to call tech support. I'll call them. Be prepared to wait on hold though. So with that being said, if you do have to call tech support, I highly suggest that you've looked at the machine for an hour or two. You make sure that you have everything written down because they typically won't call you when you're still on site, or if they do, you're going to be lucky if you get to talk to them again because they'll get on the phone and they'll say, hey, did you check this? No. And they'll say, okay, call us back. Well, then you call back, you call into a call center, you wait another 2 hours for them to call you back, and then you move on, okay? So have all your information in a row. Have everything written down. If you guys haven't seen my log sheets that I do, I have like a log sheet where I write down the model numbers, the serial numbers, the outdoor ambient, the water temperature, the freeze times, the harvest times, the pressure during freeze, the pressure during harvest, and I have all that information down there. And a lot of times when you write down all that information, you'll be surprised that you'll solve your problems before you even have to call technical support. Read the manual and figure out the sequence of operation and just watch the machine. It's just going to take time. Ice machine work, a lot of times you're left sitting on a ladder waiting for the machine to make ice. That's one of the things when you're doing ice machine work is you're bored. And on another note, management walks up and they say, why are you just sitting there? Why aren't you doing something? So move around while you're sitting there, grab a towel and wipe down the machine. And then when managers walk by, say, hey, you know what? I want you to see what I'm doing. Bring them up there. Say, hey, this is what's going on. I'm watching this machine to make sure, reassure them that you're not just standing there, that you're actually watching the machine make ice. You're monitoring these pressures and you think there might be a problem with this and, reassure the management while you're working on it. Okay. So hopefully that answers your question, bud. Another question that I had is from a user named Brad, and he said, and this is another, it seems more of a rudimentary question, but there's no stupid questions, guys, okay? So he wants to know what material I use to reattach a capillary tube to a suction line. He's going to replace one and wasn't sure if he needed to braise or use 95.5 solder. He's never done this before and mainly works on residential equipment. So there's two ways this question could go. Number one, I typically use 15% Silphos as a brazing rod. I don't use any of the low temp melting point solders. Okay. Now my next question is he asking me, how do you reattach a capillary tube? Because if any of you guys do prep table work, you'll know that they'll sometimes braise or solder the capillary tube to the suction line as a subcooling device. It's kind of like a subcooler. So then the capillary tube is wrapped around the suction line, then it's insulated, and it helps to subcool the refrigerant before it goes to the evaporator. Oftentimes, I'm going to be honest with you, if I have to change a cap tube, it's not going to be brazed or soldered to the suction line anymore, and I'm just going to install a cap tube and leave it in the air, and they're just going to have to deal with it. If you can order a new capillary tube from the manufacturer where it's already brazed to the suction line, then good for you. But I've never had very much luck being able to do that, and I'll just install it, and they're just going to have to deal with it not being brazed to the suction line. So that's my personal way that I do it. Let's see what else we got here. If I have a stuck TXV and get it moving by shaking the sensing bulb, is the TXV still bad? Yeah, shaking the sensing bulb is not going to fix a TXV, Nathaniel. If you have a stuck TXV now, disconnecting the sensing bulb and holding it in your hand, what you're doing is you're increasing the pressure in that sensing bulb, and you might be opening and closing that valve. Stuck TXVs, in my opinion, need to be replaced. Okay, you can pull them apart and try to clean components, but if you have contaminants in that system, this is just my opinion, you're not going to get them out by wrenching on the valve. Now, temporarily, what you could do, what I've done before, is take the superheat spring, drive it all the way up, drive it all the way down, drive it all the way up, drive it all the way down, and then set it back in the mid position. And I have temporarily unstuck a stuck TXV until I can go back and replace it. And in fact, I haven't posted a video yet, but I have one that I'm working on where I did that exact thing. I had a walk-in freezer that had really low superheat, too low, and they were having box temperature issues. And I found that the superheat, no matter what I did to the adjustment stem, it wouldn't adjust. It happened to be an Emerson valve too. So I drove the stem in and out, in and out, in and out, and then set it back in the mid position. And then now it's working, but I'm still going to change the valve. So hopefully that answers that question for you. Yeah, so someone mentioned here, Brandon Ali. Partstown has a lot of manuals. So if you haven't checked it out, definitely look at Partstown. So Nathaniel Crum. I think I answered your question, didn't I, Nathan? Yeah, okay, cool. Let's see what else we got here. Has anyone braised a microchannel coil? I wanted to buy my oh, you wanted to, but your company wouldn't allow you. Zach, I have not braised on any microchannel yet. You have to use a special aluminum solder. I know Solder Weld makes a lot of cool products that I have seen other people use to fix microchannel coils. But in my opinion, I'm going to tell you, if you have to use an aluminum solder on a microchannel coil, my company policy would be that it's a temporary fix until we can replace the coil. That's just my personal preference. I'm not judging anybody for doing otherwise, but it's more or less, in my opinion, going to be a temporary fix. All right. So, oh, you meant shocking using hot and cold water. Yeah. Sorry, I said shaking, but still, Nathaniel. Yeah, I would still say that all that you did was open and close the valve. I would still say that the valve probably needs to be replaced. There's still something going on there, if you're sure that it's just the TXV, for sure. So, Kenji, do I have problems reaching out to Hoshizaki tech support, or is it just you? Long wait times. Yeah, all ice machine manufacturers, unless you're like an authorized, approved warranty provider, you get the bottom of the barrel and you tend to have to wait a very long time. So yeah, all tech support. Actually, Delfield Refrigerators tech support's actually really quick, but Hoshizaki, Manitowoc, Isomatic. Actually, I've had pretty good luck with Isomatic, but I don't have to call them very often. But Hoshizaki and Manitowoc, yeah, for sure. You're going to wait some time before you get a hold of tech support, and it is what it is. So what's my HVAC nightmare? My HVAC nightmare is that I have a technician out on a job site. He got himself in over his head. He can't fix it, and I can't get there fast enough to save face. I'm extremely concerned about the way that I look to customers and my technicians look to customers. That's my HVAC nightmare. That's actually what wakes me up at nighttime, thinking about having another technician, whether it's his fault or not, for whatever reason, makes us look bad, and that is my nightmare. So, have I cleaned, scaled up water-cooled condensers? Yes, Ralph, I have. I've used Ridlime as a great resource. I've punched the tubes on shell and tube condensers before using tube brushes, just running them up and down, using soft bristle brushes. Yeah, I've done a little bit of water-cooled condensing unit. Now, if it's a coaxial condenser, you're kind of SOL unless you can run Ridlime with like a pumping station. I've done that too before, where I had coaxial condensers and even water shell and tube condensers, where I set up a pumping rig where I used a sump pump and ran hoses in and out of the rig, and then ran them in and out of the water-cooled condensers, made a rig basically, and just ran Ridlime through it over and over and over again until I can get it clean to where it wasn't fouled anymore, and then it worked properly. All right, let's see what else we got here. My other questions, guys. If I haven't answered a question, definitely post them again, guys, and I'll try to get to them. and I'll try to answer your questions here. Again, I want to say for the new guys that came in that weren't in here in the beginning, I want to say congratulations to Andrew Greaves and Tersh Blissett that made the ACHR News 40 Under 40 list. Congrats, guys. I'm really super stoked for you guys that made that list. So let's see what up. How you doing today, Ted? Let's see. See, they're Ted and Adam are gonna have problems. I might have to start. Let's see. I might have to start making more mods, and then you guys can have a mod fight. Start kicking each other out. Let's see what else. Here, yeah. What's up? There we go. Now you guys can have a mod fight. All right, let's see what else. You just pulled a water-cooled condenser out for a Bally walk-in. Oh, there we go, Nate. I wanted to answer that question. And used a D-line bucket to descale it. Sure. So, Nate, you asked me if I worked on Bally equipment. I've worked on older Bally equipment, nothing new. It's been a very long time. But, yeah, some older at a hospital that I used to do work for. They had a lot of Bally walk-ins, and I used to do a bunch of work for those. But nothing new at all. So, all right, let's see what else. Any issues with smart probes and temperature clamps at low temps, Nathaniel? Yes, I have had that issue with ones. I did hear, and I've had the issue. I don't use the Testo ones, so I've only used the field piece ones, and I have had issues at low temps where I notice weird, funky readings and different things. I did hear Jim Bergman mentioning on a podcast about it recently, and he said that he thought it might have something to do with the batteries, different types of batteries that work better in low temps than other batteries. So that's something to think about, and something that I'm going to try to do is try to find a battery that works better in a low temp. I don't know if that's like a lithium ion battery or what, but I'm going to research that. Let's see what else. Now Ted and Adam can knock each other out. So, all right, let's see. Jeff Goley, ask one more time. So let me see, Jeff, where we at? How do I feel about Taylor ice machines? I've never worked on a Taylor ice machine. Okay, Jeff, I see your question now. You checked a custom 4-drawer lowboy refrigerator, and for some reason they thought it was a good idea to mount the evap on the back wall on the right side top left drawer. Won't drop below 42. What do I think? Jeff, dude, send me an email with more information about what the manufacturer is, and I can definitely answer that a little bit more. If you can send me some pictures, my email is hvacrvideos@gmail.com, and I can try to help you out a little bit more. I do work on a lot of prep tables, so send me an email, Jeff, and we can talk about it. There's a lot of things that I could do. So let's see what else we got. Do I read a lot to be so knowledgeable on things? You're 22 years electrical and 7 years HVACR. Yeah, I'm a curious person at mine. Brad, I'm going to tell you, to be honest with you, one of the big problems with me is I'm insecure and I don't like to show people that I don't know how to do things. So I will fight tooth and nail to try to figure something out before I have to admit defeat. But at the same time, I have learned to not get involved in situations that I know I'm in over my head. But yes, I do read a lot, and I have had to do that. And, it's just one of those things. I think it's part of my mental crap that I have going on. I'm just a very person that just likes to really dig into stuff. So, all right. Let's see what else we got. Yeah. The Adam and Ted channel where they just fight back and forth. That'd be a funny one, huh? Okay, let's see. What other questions did I miss, gentlemen? Definitely post them in there, and I want to make sure I get your guys' questions answered. Mark Daly, I don't really work on a bunch of Aeon stuff. I've only worked on Aeons maybe 3 or 4 times. Nothing super technical. I didn't need computers to program them or anything like that. They were just dumbed down Aeon units. So, fighting to learn is important to success. Definitely. Just general curiosity about how things work. And, that's very important. If you just research, man, just lots of research. It's so different now that we have the internet. When I was learning as a young kid, the internet wasn't a very easy thing to use. I mean, hell, my parents were so protective that I don't think I even had the AOL password until I turned 17. Like, no joke. I think I might have had it at 17, but for most of my life, I couldn't even get onto AOL without my parents logging me in. But nowadays, it's just so funny, though, because I came up in a time before the internet, so I had to learn by reading books and different things. And then nowadays, you can get so much information on the internet. And we have these great smartphones, that have everything inside of them. We have a million different apps, and You know, we can do all kinds of stuff, and you know, it's just amazing, the different apps, you know, Copeland and different things that we have inside of there, and all the information. You know, I used to keep books with electrical manuals and all kinds of different. I think you guys have a good thing coming up for you because you have access to the internet, which we didn't have when I was coming up. So, all right, let's see. Have I ever worked on a Converon box? No, I have not. Spacey Funk. Sorry, bud. All right, let's see what else. All right. Do I service my personal home AC system? Yeah, it's very, very, it's not maintained as good as it should be, definitely. One of these days I'm going to release a video on how poor the airflow is on my home system and how crappy the 4-ton is that's in a closet that, and before I moved here, someone put a 4-ton where we should have a 3-ton system. So it's got high static pressure. It's got all these things. And it's just one of those things I just never really chose to fix. I'll get to it one of these days. But the funny thing is that my wife needs the fan on our, furnace to be running, okay, or air conditioner, whatever you want to call it. But on the air handler, my wife needs the fan running to be able to sleep. That's how noisy the fan is on our system, because we have a single return. It's super small. It's loud. And my family if we turn off, like my thermostat is set to turn the fan off at like 6:30 a.m., everybody wakes up instantly because they're so used to the noise that it makes. So yeah, my system is very, very poor condition, and it's just one of those things I just haven't chosen to fix. So, okay, so Glenn S., I missed your question about a 40-year-old tap-in R22 system. You're replacing the indoor heating system. Don't really want to replace the cooling system. Should I replace? Oh man, yeah. If you're replacing a 40-year-old system, Glenn, I really, really think to really think that you need to consider changing everything. I wouldn't suggest putting an old air conditioning coil on a new air handler or vice versa, especially on a system that old. I think it's really, really time that you consider replacing, bud. And if you're going to do it all. I hate to say it because the older systems, they lasted forever, but when you come to the new stuff, man, you're just going to have nothing but problems. So I highly suggest that you do that. How do you leave and come back? Adam has a wrench. That's funny, huh? How do you use ERUs on the West Coast? ERU, energy, you mean like an ERV? I don't know what you mean by ERU, bud. Joe, give me a, okay, give me some context there, bud. Let's see what else. Going down here on the list. Let's see. What am I missing here? I think I've answered your guys' questions. Any more questions, throw them in here. We're probably going to start to wrap this up, gentlemen. Are Elle leak detectors any good? Are they worth the money? I don't think I've ever heard of Elle. Isn't Elle Tech? I don't know that I've heard of them, bud. My personal choice for a leak detector, I'll get to your question there, curious. Bill, I see you. My personal preference on a leak detector is the Detect Select, and I'm very, very interested in the Detect or the Infocon Stratus, which is the new one that's supposed to replace the Detect Select. I'm very interested in that one, but it's an $800 leak detector, so I just haven't really ponied up to buy that one yet. But I would very, very much be interested in trying out the new Infocon Stratus. So, Bill, I see your question. Could a low charge on a system with a scroll cause the scroll plates to separate? I don't know about a low charge there, Bill. I don't know if a low charge would cause the scroll plates to separate. That's an interesting question. Send me an email, Bill. We could talk about it more. hvacrvideos@gmail.com. Okay, let's see what else. What's the best vacuum pump out there these days? Nate, Refrigeration. So I'm partial right now to the Field Piece VP85, I think is what I have. I really do like it. It's a cool leak vacuum pump. Before that, I used the JB7 CFM for 10 years. I mean, I've gone through a couple different ones, but I mean, they've lasted forever. So, you know, the JB is really nice too. It's heavy. The Field Piece is nice because of the access to the ports and different things. And it has the 2 3/8 ports, the 1/2 inch port, and the 1/4 inch. So I really like that. I've heard a lot of good information about and a lot of good reviews on the Navac pumps too, which actually is the same company in my understanding that makes the Field Piece pump. So my money would be on a Navac pump these days, or a Field Piece pump probably, is what I would be purchasing. personal preference. Okay. Let's see what else. What is the best vacuum pump? We got to that. What makes scroll plates separate? Zach, we'll have to talk a little bit more about that. I'm not going to answer that one because I'm not super smart. So about the compressors. But they do have a device inside that whenever the pressures get to be too high, I believe they separate to try to. That's why I want to be careful about answering that one. I need to do some research to be able to properly answer it. Let's see what else. If Chris doesn't answer, so Xander, let's see, what question did I miss from Xander? Please answer your question. Xander, I don't see your question there, bud. Let me go back up here and see if I see your question, Xander. Xander, it's like way up here, bud. Can you repost your question, Xander? Whatever it was, I don't see it. Just post it in caps lock. Oh, VP. So Zach, VP85 with True Blue hoses. Yeah, Zach, that's what I use right now is the VP85 with True Blue hoses. So. And Bill, I haven't watched your new video, your part 2 of the AC compressor that was murdered. I haven't seen that one yet. I saw it pop up. I'm going to watch it here soon. Yeah, so Timothy not, I don't know how you pronounce your last name, Timothy, but so yeah, I did just talk about the Measure Quick update. I haven't used it yet, so I'm super excited. If I get my hands on some gauges tomorrow, I'm gonna try to use the new updated Measure Quick refrigeration profiles. I'm super stoked to try those out. I'm a big fan of Measure Quick, so let's see what else. All right. Why do you get oil in your gauge hoses when doing a vacuum? That's a problem with the system or with the vacuum pump. There can be a couple of things. It depends on which way the oil is coming from. Are you sucking the oil out of the compressor or are you sucking the oil out of the vacuum pump? I don't know where that's happening from. I have heard of systems like that where if a vacuum pump shuts off, it'll suck the oil into the system. I've heard of some weird things. So it really depends on what your vacuum pump setup is there, Raphael. Ever hear of Builder's Book Inc. out of Canoga? No, they have a rule of thumb for HVACR. No, I haven't, Ray. I'll have to Builder's Book out of, is it Canoga Park, California, Ray? I don't know where you're, Canoga. I'll have to look that up, Ray. Send me an email on that. Hey, thanks, Bill. Appreciate it, bud. Send me an email on that, Ray, and I'll check them out. Let's see what else. Yeah, any of you guys, if you haven't already, do me a favor and hit that thumbs up button. It really does help my stream out. I really appreciate it. And thanks to everybody that's coming in here. This is awesome. I'm just trying to answer your guys' questions, so any more, throw them in here. It's a very good possibility. Like Ted says, an overfilled pump, definitely. So, see what else we got. And the question that I haven't seen someone repost your question yet. Whoever I just said that to a minute ago. Post it again. Let's see. Zach, thank you very much, man. Good vacuum pumps have protectors. Yes, they do. So what I found out, though, was I think I even found out that the field piece pump doesn't have a solenoid inside of it. But I do know that the Navac pumps do have the little check valve or solenoid valve inside of them. I have heard that the field piece pump has something so that way it won't leak when it's tipped over or something like that, but I don't know that they have a check valve or a solenoid valve inside that shuts down when the power gets powered down. I think you can lose your vacuum still. All right. Yeah, repost your questions, Xander, because I don't see it yet, and I'm going to try to do it quick so that way I can get to this. Just copy your question and hit Control-C and then paste it, Control-V in the chat again. So I really appreciate it, Bill. That was awesome of you, bud. All right. You're about to let the wrench fly. You're going to throw it across the room there, Adam. All right, let's see what else. Any more questions, guys? Throw them in here. I'm going to end this at 6:30. So why would an oil pump trip on a compressor? Leo 1984. There's a lot of things that can cause an oil pump to trip. You could have dirty screens. You can have an oil pump. That's not where I'm assuming you mean oil pressure safety. There's a couple different things that could be causing it to trip, man. Low oil, obviously, different things. So it's hard to say. I'm not a super big expert on the oil pumps controls and stuff like that. I don't work on the systems that usually have a lot of oil failure controls and stuff, but I do understand the concept of how they work. They're just a differential, looking at differential pressure. All right, let's see. What's my opinion on apprentices working alone? Xander. I'm not a fan of apprentices working alone unless it's something like, you know, a remedial task that they know how to do and you send them to just go do something for you that they understand. Ted, dude, that's awesome, man. I really appreciate it. Thank you, Ted. So yeah, I try to have an apprentice with me as long as possible. Unfortunately, my apprentice isn't working for me anymore due to unforeseen circumstances. He was a great technician. He didn't do anything wrong with our company. He was a great guy, but it just didn't work out. But I was bummed out that, you know, he's not working with us anymore. So I do need to find more help as usual. So seems like a never-ending revolving door. Let's see what else we got. When you are calculating superheat for a reach and freezer, if the line temp is negative, do you add that to the saturated temp to get the superheat as the line temp is a negative? So what I do, DM Locksmith, is try to remember that superheat is a temperature difference between 2 points, and try not to look at the math so much as what's the difference between the two numbers. Okay. So try not to do, like, I used to get confused when I was looking at superheat and I'd say, well, I have a negative suction line temp and a positive number. Do I add it? Do I add them? Dude, that's awesome, man. Thank you very much, Adam. DM Locksmith. So just try to look at it as the difference between the two. So if you have negative 10 and you have a 10-degree suction line, what's the difference between the two? Okay. And so that would be what, 30 degrees superheat. That's how I would do it. So hopefully that answers your question there, bud. Adam. All right. You guys are funny, man. Let's see what else. You think you remembered seeing JS Studio. Oh, okay. All right. You think you remember seeing something like that on the late. I don't know what that is. Let's see what else. A-Team is busy and not paying attention. Adam, you're the man of the night. Yeah, you are awesome, Adam. You are the man. Adam, you had said something earlier. I saw your comment come through. I didn't know what you meant. What did you learn from me? Did I help? I know we were talking about the wine room thing. Is that what you were talking about? Or were you talking about something different? Let's see what else. Late Aussie 50s channel. Yeah, I don't know if I know that channel. So, Adam, you the man. Oh, okay, so Super Chat Hero. Yeah. Sadly, he committed suicide. Oh, I didn't. I know there was a YouTuber that did that recently. I didn't know which one it was, but Icon. Am I missing a question here, bud? Let's see, Icon. Is my question not showing up? Yeah, just post your question, Icon. I don't know what it is, bud. Flood back will trip. Yeah, flood back will trip oil pressure too. There's a lot of things that can trip oil pressure. So, being set. Oh, okay, got you. Saturation temp on a refrigeration being set. Your TXV not pressure. Yeah, got you. I see what you're saying there, Adam. Oh, okay, got you. Said my name, JS Studio. Oh, okay. All right, gentlemen. I really appreciate it. I think we're going to go ahead and wrap this up. Wait, let me see this. Fluke196, you think mental health and trades needs to be discussed more? Yeah. If you guys haven't, that is a definite thing that I think we need to talk about more is mental health. Mental health is a very important thing. I could go off on a rant on that one, okay? I have mental health issues. I've gone to see a therapist and figured out I had issues. I took medicine for it. Whether or not, I'm not judging for someone for taking medicine or not taking it. I chose to go that path. I've talked about it in depth on a stream that I did with my wife where we talked about my anger issues and different things that I had to deal with. It's very important because this can be a very stressful job. It can be, especially when you're a business owner or you're a principal of a company, there's a lot of stress, and mental health is a very, very important thing. So definitely look into it. Hey, JS Studio, let's lay off the silly emoji things, okay? I don't kick you out yet, but just try to take it easy. Yeah, I really appreciate it, guys. I'm going to go ahead and wrap this up. Thanks so very much for coming in here. And any questions you guys have, hvacrvideos@gmail.com, and I will try to answer them for you, okay? Really appreciate it, and let's go ahead and transition on out of this, and we will catch you guys on the next one, okay?